Okay. Well, hello everyone. Um, my name is Sandeep. I'm
Actually,
here to.
sorry, I'm going to cut in really quick. We're getting a little bit of wind.
Okay, okay. Yeah. Let's see. Could you blur me out for 1 second so that my video is. Let me see. Sorry. Just give me 1 second. Okay. Just give me just 1 second.
There's supposed to be two people in person, another person in Monday. So I just haven't had anybody else pop up yet. So.
Well, we'll see. If you wanted to move the camera, you can. So you can move it with these buttons to the screen or not. So you just have to point to the green screen and press and hold. So it takes a little while to move. And then you can potentially move it over to like the lectern, for example, if that's something that they want.
Okay, great.
Just make sure that nobody moves the
camera,
the tripod.
Oh, the tripod. Okay.
Kind of, yeah, well, the whole thing. It's kind of sensitive. So
okay.
It's better to do it.
No problem. Sweet, thank you.
Oh, and people who are registered for the gym don't need to sign the form thingy.
Yes.
So yeah. It doesn't matter if they do.
Okay, perfect. Yeah. Sandeep, can you still hear me? Give us 1 second, everybody. We're still troubleshooting a little bit.
Okay.
Hello, can you hear me?
Yes, yes, yes.
Okay, perfect.
Okay. Are you able to hear me okay?
Yes, sound is great.
Great. Awesome. Okay. So whenever you give me a go, I'm ready to start.
We are ready when you are. Go ahead.
Awesome. Okay. Okay. Thanks everyone for joining. My name is Sandeep. I work at the Trend Center in Atlanta, Georgia. Um, and I'm going to present our software called COINSTAC. And it's a framework for doing collaborative big data research. And it falls in the category of federated learning and privacy preserving software. So some of you may have heard about this presentation last year from our colleague Eric Werner, and we have improved and updated an important feature this year. So I want to share some exciting news about that and get your feedback. So this is the overview of the presentation.
Could you minimize the slides on the side so that we can see your full PowerPoint screen potentially?
Okay.
Perfect. Thank you.
Okay. You're still able to see my full slides, okay?
Yes, we see your PowerPoint view.
Okay, great, great. Okay. So here's the overview. I will briefly describe COINSTAC and what it does and the framework. And I will present a use case, which I think will be uh, important scenario for um, this conference and see how it fits into that use case. I will also describe some of the features of COINSTAC, and the most important thing I will talk about is the vaults that we introduced into COINSTAC recently. And there will be time for feedback and questions at the end, but if you do have an important question um, in the middle, you are welcome to post it. And yeah. So um, I want to give a general overview of where COINSTAC comes into play in the modern day brain research. As we know that there's been an increased trend towards big data collaborative projects globally, um, and with increased hardware processing power and just global networking and just the amount of data we collect, we are able to do so much more research with precision, and with more confidence, we are able to achieve results that were not achievable before. So where COINSTAC comes in is it presents a platform that will allow different sites to collaborate on big data projects without having to share their physical raw data with each other. So users will be able to collaborate on a project, and they can run an algorithm or a computation, as we call it in the COINSTAC framework, on their data. And the data will reside in the local geographical area where they are. And only the algorithm runs the processing on the data, and the results of the processing will be shared across the sites, and the computation global model or whatever algorithm is in play will update the results and communicate back to the sites. So that's the framework. So it enables analysis without sharing the data, allows for better collaboration with other people, and sites with sensitive data like HIPAA can have a better chance of collaborating with people across the world in using our framework. And as of now, we've implemented quite a lot of machine learning computations in our software, including differentially private computations. And I will go through a quick overview of COINSTAC and the benefits of it. As we know that the more data we use to train our machine learning models and different algorithms, the better they are at predicting or giving more results with a higher confidence interval. And this also helps with public transparency and reuse of data, and just increased visibility of the work. And here are some obstacles to data sharing that we just encounter in our research field. So it can be misuse or misinterpretation of data, and preserving the subject privacy, and not having enough permissions from the institution to share the data with each other. So our application is a standalone application that can run on various operating systems, whether it's a Mac or a PC or Linux. It has a nice user interface, which I will go through in the next couple of slides. So here I will describe briefly just the way the software works. So basically, the computations are, or the algorithms that our software supports are packaged in Docker containers, which are basically independent of operating system. They can stand alone on any operating system, and that's how we are able to make this more user friendly. And because the environment in the Docker is locked in to that computation, we don't have to deal with um, various versions of operating system updates and such. It will be reproducible pipelines the way our software is built. Here's a little bit more information on the technical specs of it. I won't really go through it in detail. If need be, we can come back to this slide. So the way users can participate in a consortia is by creating a consortia, which is simply a project where people collaborate together, and there is a consortium owner who initiates this, and he invites other people to join the consortia, and the owner initiates what computation he wants to run, and he sets all the options for the pipeline that he would like to run in that project. So after that point, users will basically map their local data, which should be in a format that the computation is able to receive. And once all the users who are added to that consortia map their data, then the algorithm is ready to run. And in this last piece, you're simply seeing one of the results of the computation. So as I said before, the data at the local sites remains at the local site. And once the data is mapped, then the algorithm runs on that local data, and it sends only the processed results, which is, for an example, in this case, let's say we are trying to train a model for prediction. And only the weights, the beta weights, are shared with the central node, and they are aggregated in the central node, and the model is updated, and the weights are sent back, and it's an iterative process depending on the algorithm. So the data still remains locally. So one of the important reasons why this software works is because the results of running the software locally on your computer versus in a uh, decentralized environment like COINSTAC, the results are still comparable. So in a sense that the results are interpretable in the same way or similar way as if you would run this locally on one machine. So that is the important for research, right? So and in this case, we are showing you a algorithm called TSNE. It's an unsupervised dimensionality reduction technique that we ran on just handwritten digits and see if the digits separate well if we run it in this COINSTAC framework. And as we see that they are still distinguishable. We have done other results and compared them of running, say, joint ICA in outside of COINSTAC versus in COINSTAC. And we have published multiple papers on how the results are comparable. Here are the existing computations that are in the COINSTAC framework as of now. And as you can see, there are algorithms ranging from just the pre-processing to running models like regression to machine learning and deep learning. So we have a variety of computations currently available, and our goal is to accommodate as many research scientists as possible in what we think would be valuable to the research. And we have upcoming computations, which include adding bits compatibility for structural MRI data, specifically the data that is processed through the VBM pipeline, voxel-based morphometry. We currently have the bits compatibility for um, running on the functional MRI data. And so this is in the works. And we also have other tools that we are looking at to integrate in the near future. And one of them is HalfPipe. I believe Leah Waller is presenting on HalfPipe in the next session. So you're welcome to check it out. So the idea here is to accommodate the research tools that the scientists are using in their organizations as of now, and include them in this framework so that we can help with the goal of global big data collaboration. So another one that we are working on is a deep learning model with sparsity, where we are able to reduce the number of parameters that need to be updated and transmitted across the sites, and to facilitate deep learning in this framework. So, and in the future, there will also be multi-model computations. So here's the use case that I want to discuss. so, so let's say that we are in a place where there is limited hardware, whether it's a different part of the world, and another company with limited hardware resources, and there's not enough collaborative opportunities for networking, and the projects are living in their own ecosystem. So it's really hard to collaborate with other people and assume that the data is sensitive, so there will be sharing issues. Along with that, if we add the problem of maybe not enough people having the technical coding expertise, and they have a specific choice of programming language, but they want to do collaborative big data research with other people in the world and answer important research questions that require a lot of data and which they may not have collected in their study. And this is the use case in which we believe that COINSTAC will come in handy, and it does an amazing job, because COINSTAC is able to run the software in a decentralized way and differentially privacy preserving way, where if the user, say, has 1,000 data points and he does not have enough hardware to run, he is able to split that into multiple sites and use COINSTAC framework to run and gather the results and interpret them in a similar way as if he would run individually on his machine. Now, coding expertise is one of the very important things in using these kind of frameworks, and that is an area that COINSTAC has put a lot of time and energy into in developing a user interface where users are able to select computations and algorithms and run it on their data. There are other software in the current research field, like um, say NVIDIA Flare, or like the Python package. I'm spacing out on the name, but it requires some coding skill. And this is where COINSTAC simplifies it, where our developers have put the computations in a user interface that is easy to select and add data to and run the algorithms. And I will show you the interface here soon so that it all comes together. Okay, so the newest feature that we want to introduce is called the COINSTAC Vaults. And vaults are basically persistent data that is available on the server at all times. Users can select that data and run the computations on them without having to worry about having the data be online or their machine being online and such. And the data is already pre-mapped to work with the COINSTAC computations and organized. And it's accessible at all times. And users are able to use their local data. Let's say they have only 100 data points, but they want to do a bigger study with, say, human connectome project or different things. And we have some vaults available on COINSTAC, and they can combine their local data with our vault and run the computations for a bigger study. So here, I will show you an interface of how this runs. Okay, so here we log in using our username and password. And first step is to create a consortia. Give the name, description as needed. Then we select the pipeline. So here we have data from 885 children, and it's a freezer for volumetric measurements from the Killarney Atlas. And we are selecting that vault data now, and we are going to run a rich regression on that data set. And these are all the measurements that we have, assessment data that we have for them. And users can select if they want to include some of them or remove some of them. And they can select a specific region of interest for running the regression on. And they will notice these outputs after the computation is run. We save the pipeline, and we go back to the consortium, and we set the pipeline, active pipeline that we just created, and we start the pipeline. So it's running now. You see the progress. And here are the results from running the regression. So this is an example of how vaults work. In this case, the user does not need to have their local data. They can simply use the data that we provide that is accessible at all times and run a regression on them. If they do have the local data, they can attach the local data to this consortia and use it in combination with the vault. So we have another vault also that we added. It's structural MRI data that is processed through the VBM pipeline, and it's about 152 subjects. And these are all the cognitive measurements that we have for that data. And in the future, we are going to also have another vault on which users can run the group ICA. And if users want to share their data as a vault and make it accessible to other users across the world, so that they can facilitate a little bit more collaborative projects, that's a feature that we are working on now. So they will be able to add their data as a vault in the COINSTAC framework, and that will be available to the COINSTAC users at all times. So here are some other results that we ran using the COINSTAC framework. This is a regression on the VBM, and this is the dynamic functional connectivity. And here's a huge study that we ran, involved about 2,500 subjects across 14 sites, and fMRI data. And this was a substance use study. And here you notice that alcohol has more effect than tobacco in this specific substance use study. And the important thing here is to notice that this is a very huge task. If outside of COINSTAC, this typically takes a lot of effort to run, and we were able to run it using COINSTAC across 14 sites and derive meaningful results. And these are the kind of studies that we want to do with COINSTAC framework in places where there is a privacy data sharing issues or limited hardware that. And we feel that framework is just a great platform to promote research in a better way. There are multiple ways to contribute to COINSTAC, and these are some of the things that we are looking for, and is for users to just be able to run a research project with COINSTAC. And like we have shown you, there are at least 15 different computations or algorithms available on COINSTAC right now. And it's live, so users are welcome to try them. And we would love to see how COINSTAC can answer interesting research questions in the future. So the other way is to contribute to the code base of COINSTAC. And we have a streamlined process for that. It's okay if you choose a different programming language of your choice, whether it's Python or R or any other one, because we have a process of packaging it into a Docker container and freezing the operating system environment. And next, we basically test the code to work with the simulator, COINSTAC simulator, and adjust the inputs as needed, and then the integration process. If it is a new code, we have the documentation for how to go about this process. If an organization has their already developed computation that they want to include in COINSTAC and run a study on that with other people, we can accommodate that as well. And the standardization of the data is only needed to the degree to which the algorithm itself is able to run. If the data works with the algorithm that is included in COINSTAC or you want to create, and we expect the other users in COINSTAC to have their data organized in a similar fashion. And if it works with the computation, it works with the COINSTAC framework. So the other one, other last point is if we have any interesting big data research questions that other organizations want to collaborate with us, we will be absolutely delighted to work on grants together and potentially answer some questions that were never possible before. We have our team members attending in person at OHBM, so I'm sure they would love to interact with you if you have more questions in person or future developments or things that are pertaining specifically to your project and how you could use COINSTAC for that. Please feel free to interact with them. And okay, that brings me to the end of the presentation, and you're welcome to give your feedback. I would love to receive some feedback about just the framework in general, or any other creative ways that we can have this tool be more useful, or you notice like a present hurdles for the use case that I have presented, and any suggestions. So I have come up with a few questions for discussion and feedback as well. So I will open it up to any questions or feedback that people have at this point. Okay.
If anybody has any questions, feel free to come up to the podium and ask, or you can speak and I can repeat. Either one works. And I will move our camera so you can see them as well.
Yeah, hello. I have a question. I'm Sebastian from Montreal. Hi. Thanks for the
Hello.
presentation. My question is about something that you kind of mentioned during your talk, which I think you called the mapping of data.
That's right.
And so I would be curious how that is done, because as I understand, what you're achieving with this is an ability for people who cannot see each other's data to define analytical processes that can be run on those data in a meaningful way. So there has to be some kind of data harmonization, I'm assuming. And I would like to know a little bit more on how you are doing this.
Right, right. So the way we map the local data is we have a format for each computation. We have a predefined data set that is that works with that computation. So, for example, we can go for these are all the this is the actual COINSTAC interface that I'm actually showing you. Let me see if I can actually share that screen. Give me 1 second. I will share the actual interface itself. That will be much easier to. Okay, so let me know if you're able to see the COINSTAC interface.
Yeah, I can see it. Yeah.
Okay, great, great. So for each of these computations, we have a test data that works with this computation. So for example, I can say view test data for this, and the data is organized as in this case, it's a CSV file along with all the volumetric measurements from FreeSurfer software. So users can use this test data to run the computation, or they can go to this GitHub link and organize their data accordingly. So it does require them to organize the data in a way that works with the computation. So that is, and once their data is organized in this fashion, they are basically go to the COINSTAC interface and they can map data they select the covariates file. In this case, maybe I can try to see if I can find it. Okay, let's see. Good. In this case, covariates, I select the covariates file, and it detects the columns in the CSV file, and you can say auto map, and it maps the data to what the computation is created to receive. And at that point, you have mapped your data, and you can see the selected files, and you can save this and go back to the consortium and run. So that's the process. Maybe you can tell
Would
me
you mind if I ask
that.
a follow-up question? Yeah. No,
Yeah,
this is
absolutely.
fascinating. My question is, that works for control and age. How deep does that go? Because I guess my question is, I have PI1 and PI2, and they have both acquired some cognitive assessment tool, right? With maybe let's not, maybe there's even some domain subscales or even items, right?
Yes.
Now, how do they know that they're talking about the same thing? What are you doing, or are you doing anything to make them use the same terminology or structure or something? Like age, I understand, but these things, these covariates are probably more complex than that, right?
Absolutely, absolutely. So in that case, we are basically the consortium owner who creates the project in COINSTAC will define the covariates that, like for example, let's take this one. This is a covariates for the VBM vault data, and he defines the covariates, and he will basically guide the other members to follow the same same cognitive measurements. So he will sort of give the initial format, and users can basically map their items, like in the previous COINSTAC UI that I showed you. Users can drag and drop. Like say, for example, one project records like something related to cognitive measurement by using a different word, right? Different term. Another site uses a different word. They are able to map that together in the user interface of COINSTAC, saying, okay, this maps to this maps to this. So the local data can be mapped, even if the words are interchanged, they can map the terms with the original project owner's covariates.
Okay. So if I understand this right, every consortium within COINSTAC defines their own data model and vocabulary that the contributors to the consortium then map their own data to, such that they can talk among themselves. But if you wanted to extend this collaboration to other consortia, you would have to have a separate mapping process between their models. Is that accurate?
Exactly.
Okay. Thank you.
Yeah.
Thanks a lot.
You're welcome.
Hi, I'm Christine Rogers
Hello.
from the M&I. Hi, great talk. Thank you so much. I love just seeing everything that COINSTAC can do. And I was just wondering, and I apologize if I missed this, but how does it work with bids, or what extent is there engagement? Like maybe start with how many tools or pipelines, handle intake or output bids?
Absolutely. So as of now, we have started with including the bids compatibility for the structural MRI data, which is run through the VBM pipeline. So if we want to use the SMRI data like the T1 maps and run VBM pipeline computation in COINSTAC, it accepts bids format. So, and it was created about 6 months ago, which means that whatever the latest bids format was at that point, we used the Python package PyBids to qualify the bids package, bids data, and use it. So it works with the SMRI data as of now, and in the future we want to expand it to fMRI data and DTI and other models. So it's very much in the top priority to do, because we know the value of incorporating that, because so many it will allow for people with bids data to just not have to worry about organizing and their data in a different format or anything, and we can just consume it right away. Another one that we are working with is HalfPipe, integration of HalfPipe in COINSTAC framework, and they also consume bids format. So when that integration is done, we would be able to accommodate bids and HalfPipe as well. So that's what is in the works.
Thanks. I definitely understand how these things kind of grow out of the collaborations that use them. And so if you have adopters of bids pushing you to do it, it happens faster for sure. I had one follow-up question, if that's okay, unless anybody wanted to go, which is just that I can see how it's really useful to have consortia where you enable people to run the same tools on data. And to that end, do you have like a dashboard, maybe even that just your consortia, not owners, but lead PIs use, that show usage metrics? Is that something that you guys are developing or looking at in terms of how do people see how the consortium is using COINSTAC? How do people see who runs not who runs what, but just how often it's used and how powerful it is?
Right. As of now, users are able to search for existing projects in COINSTAC through the search tool. But we do not expose what the consortia, what kind of data and they are running or how many projects they have run. But we definitely do that for the vault data, because vault data is something that is, it's open to the public, and that's the goal of it, right? So for the vault data, we definitely expose the information, like this is the how many subjects, and these are all the computations you can run. These are the papers related to that vault data. But as for the consortia, we don't have any metrics on. Of course, if you're the consortia owner yourself, you can log into COINSTAC and you can obviously see the projects you have run in the past and who you have collaborated with and stuff like that. But it's not made public to the open world. Um, Maybe there's a creative way to do that while still preserving the privacy, so to say. Yeah.
Yeah. Maybe let me clarify. Maybe just for the vault data, do you have a dashboard that exposes how many times it's been processed using CoinStack? Maybe, I don't know.
Right, right. As of now, no, but I think that will be actually very, very good feature to have.
Okay. Thanks.
Yeah, and see like yeah, absolutely. Thank you.
Do we have any more questions, either in person or virtually? Give people a minute or so to type.
Sure, sure.
Oh, yeah. Yeah.
Hello, thank you, Sandeep, for the wonderful talk. So I was just wondering if I want to now set up CoinStack in the lab and kind of make my data set available to collaborators, like what would my first step be? Do I need a separate server? Like where would I start?
Sure, sure. Thanks for the question. Yeah. So if you have a local machine that is big enough to run a project, then you can set it up on your local machine. Like if it's a PC or a laptop, it's a standalone application. So it's available for download directly on GitHub, and it's installable in one step, 5 minutes installation process. And the only other requirement we ask is to have Docker installed, because we use that um, platform to run the computations locally. So you need to download the CoinStack software, install the Docker, and you're set to go for running CoinStack. Now, if you do want to install it um, on another machine or a server, you want to simply make sure that you would have the privileges to install uh, the Docker or use the Docker on the server. And that's doable. We have done it before. We have been able to run it on the Amazon EC2 instances. So yeah, it depends on how you want to set it up.
Okay, thank you.
You're welcome.
Any last questions? All right. Well, we can go ahead and give Sandeep a round of applause. Thank you so much for doing this emergent session.
Thank you very much. And feel free to connect with me or Vince or Sergey or Brad or Jeremy. You will probably see them in person. And yeah, we would love to collaborate with you. So thank you.
Perfect. Thank you so much.
Okay.
I will go ahead and end broadcast, and that should wrap everything up on your end as well.
Great. Thank you.
Thank you.